Okay, very short video here. So Statistical Rethinking, second edition, question 7M3 from chapter 7. I'll just read the question out loud. So when comparing models with an information criterion, why must all models be fit to exactly the same observations? What would happen to the information criterion values if the models were fit to different numbers of observations? Perform some experiments if you are not sure. Okay. So just regarding this last part, I think that the answers are simple enough that I won't run any experiments. If you do, I would be curious what you did, if you wouldn't mind sharing those. But so let's just kind of get our bearings here. So when we're talking about information criterion, we could be talking about some things that we've already mentioned in this chapter. So WAIC, or maybe something like AIC, and there's others like BIC and DIC, but we're talking about these types of measures. Okay, so there's two parts to this question. One is why must models be fit to exactly the same observations, and what if they are fit to different numbers of observations? So we'll take those one at a time. So first, why must all models be fit to the same observations? And this feels too simple to even have a coherent answer, if that makes sense. It feels almost like a tautology. It's not quite one, but it very much feels like one. So I think maybe the best way I can answer this is with an analogy. So if we're asked to compare, instead of models, two sports teams, and team A is a basketball team representing the qualities of one model, well then we better hope that the other team is a basketball team, right? Because if we're going to be comparing them, then we hope that they're engaged in the same activity, participating in this by the same rules, etc. It wouldn't make a lot of sense, or the comparison would not be easy to interpret if we were comparing a basketball team to a soccer team, right? And so in the same way, if I want to compare this model to that, I have to make sure that they're being tested on level ground, so to speak, right? They have to be tested in the same circumstance. Otherwise, it's not even a test, right? So anyway, so that's my answer to the first one. Like I said, it's almost hard to answer because it is too obvious. Any language that you use around it just seems to encompass an answer. Okay. Okay, but the second part is a little bit more interesting. So what if the models are fit to different numbers of observations? So let's take this to mean, let's say that model A is fit on 100 data points, and then model B is fit to the same data points, but only 90 of them. Okay, so they're being fit to the same data. It's just that model B is being tested against a subset of the data against which model A was being tested against. Okay, well, the reason that this would not be very good, so they're being tested on the same data, it's just that one is being tested on less of that data, is because of the definition of WAIC and AIC, and in particular these summation signs here, right? Okay, we are summing the mistake or the deviance in prediction of our models against each of the data points, right? So each data point has its own error, or its own its own error associated with it, or its own deviance value associated with it, right? And so if we have more values, we're going to have more deviance values, and that's going to drive up the information criterion score, and that's going to imply a worse fit. So even if you had two models that had exactly the same WAIC when tested on the same set of data, if one of them is tested against less data, then it's going to typically have a better information criterion score, which will suggest that that other model is a better fit, even though we've just specified that they should be the same fit. Okay, that is it for this one.